All right, for those of you listening at home, howdy. This is Monday the 16th. In one of 2 days, we're actually going to be live. Don't get me started. But please take out your homework. It was augmented region matrices. 4H is in parallel. I'll be coming around to check that in just a moment. People who are at home will talk as far as how to check this out. All right. You know, this is kind of I'm going to, okay. I was going to say, well, maybe I can just edit this out when I get home. It's like 2 minutes of extremely boring watching me walk around and do nothing. Whatever. Don't scare us here, people at home. Possibly.
Yeah, I used them to piece of paper because I was like freaked out, and then I didn't really big numbers that are
People listening at home, we're getting there. I know you're impatient.
Oh, that's
I thought I saw it.
I'm literally going to.
All right. I don't know if anybody can see me off screen. I'm still here, honest. Let me read out the answers. There's one triplet of answers. They're as follows. X equals -4. Y equals 1. Z is equal to 3. And that is it. -4, 1, and 3. I was going to say any repeats, but that would be kind of dumb. So, -4, 1, and 3. There you are. There's your repeat. This is going to sound almost equally dumb with questions. Before you do number 1, could you please do number 1? Would anybody like to see me demo this? Okay, I see at least a few heads bobbing. Let's do it. Somebody do me a favor and read this thing off. It's x minus 2y plus 3. Whoa. X minus 2y plus 3b. I got that one. Equals, and I don't know what. 3. Okay, what's the next one?
2x plus y plus 5z equals 8.
Okay, thank you. And the next?
3x minus y minus 3z equals -22.
Negative what?
22.
22. Nice, thank you. First of all, I would fill in the missing numbers. There's a 1 in front here. Add the opposite, add the opposite, add the opposite, fill in the 1, fill in the 1. So first step, give me an augmented matrix. Somebody, for example, Rainy.
1,
Uh,
2, 3, and 3.
Good, keep going.
And then 2, 1, 5, and 8.
Okay.
And 3, -1, -3, and -22.
And -22, good. I'm going to call this row A, row B, and row C. What do I target first? I mean, what do I want it to, Renee, finish this off. What do I want it to look like when it's done?
1, 0, 0, and then something. 0, 1, 0, and
Something
0,
else.
0, 1.
Right. What is this thingy on the left-hand side? Anybody It's the 3 by 3 identity matrix as I3. So I want the left to look like the 3 by 3 identity matrix, and I want the right to look like something else, and something else again. What do I target first? What do I try to get rid of first? Where do I start aiming, so to speak? Violence, purely metaphorical. For the people listening at home, before they report me to the FBI and they get hauled off and chained. So, where do you attack first? Look at your notes if you need to. Which of these numbers needs to be on the firing line first, so to speak? Yeah.
Would be like 3 and 5.
Yeah, the 3 and the 5. I'm going to do these first. We're technically going down like this. We'll hit the 3, then the 5. But you can theoretically do them at the same time. It's actually pretty efficient if you do. If I wanted to cancel the 3 and the 5 at the same time, I have to use what as my club? Yeah.
-3.
-3. These are the key numbers. So this thingy here, this thingy here, and this thingy here. Those are also your clubs in the sense of beating something. So if you say, you ever play this game called Whack-A-Mole? It's got this thing with a, like, I used to call it Whack-A-Weasel because it sounded more fun. But they would pop, this little plastic mole would pop its head up, and you'd have these big padded mallets, and you usually have 2 of them. Man, was it therapeutic. You had a hard day. You'd say, all right, and there's like 10 holes, and there's like a, they start popping up at random. Yeah! Man, it's great. But the reason this is kind of similar, these are your clubs. I assume you have 3 hands for this. But you have to start beating this and then this first. But the question is, what number is big enough to handle 3, 5, and -3 for canceling purposes? Becca? 15, yeah. So I want to get this row to plus or minus 15. Now, I'm using C as the club, but first, let's get them big enough. What would you, go ahead, Becca. What would you multiply the top one by? 5, definitely. So 5A is the code. And then what would you do for the second one?
3.
Yeah, 3B. And then how about C? 5. That looks perfect. Go ahead and do that for me.
So it'd be 5,
Uh,
-10,
Good.
15,
Uh-huh.
15,
15. Next one?
56,
Uh-huh.
3,
Yep.
15,
Uh-huh.
and
24. And last but not least.
15,
Uh-huh.
-5,
Okay.
-15,
Yep.
and
I apologize. Sorry. I do 5 times 20 and 5 times 2 and put them together.
-110.
-110. Good. Everybody with me so far? All right. This is now my newly, I was going to say newly sharpened club, but that makes no sense whatsoever. You sharpen knives, you don't sharpen clubs. Whatever. Your newly polished club. You're going to use this to beat this and this. So you can do them at the same time. What code? I'll use the first row and the second row. Josh, take over. What did I write here?
Should be A plus C.
Yeah, A plus C, and then this one is
B plus C.
B plus C. I'm going to take C for club. Bam, and then bam. Go ahead and do that for me. What is the new top? Let's flip this.
It's going to be 20
Okay.
plus -15.
Yep.
0.
0. And then, yeah, that's a funny.
95.
-95. Nice. Give me the next one. I'll write it.
So it'll be 21.
Yep.
-2.
Uh-huh.
0.
Yep.
And then
Negative something. What I do is subtract 20 and then subtract 4. Or, well, add 20 and add 4.
it'll be 86.
Yeah, so -86. Okay. And then the bottom stays the same. 15, -5, -15, -110. Okay. we have succeeded in going bang, bang, wiping out those first two numbers. What I would suggest, I don't even know what two words I was trying to say. That just didn't work. What I was going to suggest is that you do something before you target the next number. What would I suggest? Yeah.
Oh,
Reduce, definitely. It makes your life a lot less miserable. Does the first row reduce?
Yeah.
By what? By 5, definitely. So you do A divided by 5. Does the second row reduce? It does not. I'm going to erase that. Does the third row reduce? Oh, math people. Actually, go ahead.
Yeah, by 5.
Yeah, by 5 again. So C divided by 5. Again, it's an extra step, but it makes math much, much easier in their head at least. Go ahead and do those rows for me. Divide the top row by 5, if you would.
4,
Good.
-3,
Uh-huh.
0,
And, yeah, sorry.
and
Negative something. You're welcome. I do it.
sorry.
No, that's okay. Higher. Well, how much times is 5 going to 9? Once, and then there'd be like 4 left over. How much times is 5 going to 45? No, okay. It's fine. So it'll be 19. Go ahead and do the bottom row for.
3,
3,
-1,
negative 1,
-3,
negative 3,
and
and yeah, right again.
22.
Negative 22, correct. And then the middle numbers rows stay the same. 0, negative 56. Okay? Now, take over. Courtney, what would I target next? What's next on the,
So we just did the 2 zeros, so now we want to do the -3,
the negative 3? The upper one or the lower one?
the upper one.
Definitely the upper one. So how do you target that? What do you use to target it? What do you use as your club?
The -2.
The negative 2, correct. We're going to use negative 2 as the club. Do not use C as the club, because it's tempting because they match up pretty nicely. But it's more of a pain in the neck to use A and B, but you must use the club. If you don't, you're going to start contaminating your answer and undoing the zeros that you already did. I've done it, trust me, and it's really depressing. So, what number would be big enough to handle both of these? 6, definitely. I want to get these up to plus or minus 6. I do not have to mess with the bottom one yet. So just play with the top 2.
You multiply by -2,
Okay? So negative 2a.
and then 3.
And that sounds good. So one of them has to be positive, one has to be negative. What does that give me? Or you, us? Multiply the top by -2, if you would.
So -8,
Good.
6,
Uh-huh.
0,
Right.
and then 38.
Yeah, 38. Good. And then the next one, multiply by 3.
63.
Yep.
-6,
Uh-huh.
0.
And yeah, sorry.
Is it negative
Negative something.
258?
Negative 258. Good. Negative 258. And then the bottom one keeps the same. 3, negative 1, negative 3, negative 22. Now remember, I'm trying, which row am I trying to modify next?
Me still?
Yeah, please. Yeah, I know. The death of this number is going to be on your head entirely.
A.
Yeah, A. So, how do you write that? What's the code? Where's your club?
You would do A plus B.
Exactly, A plus B. Go ahead and do that for me. I gave you a fun one, didn't I?
Yeah.
What's 63 plus negative 8? haven't killed your prey yet.
55.
There you go, 55. Keep going.
0.
0. Don't work too hard on the next one, thank you. And the other one?
220.
Yeah, negative 220. Okay, leave everything else alone. 63, negative 6, 0, and negative 258. And then the bottom one is 3, negative 1, negative 3, and negative 22. Okay, there you go. Yeah,
Can you
question.
have this go to the bathroom real quick?
You may. Megan, take over. Well, what would I do before anything else?
Reduce.
Definitely. Does the top reduce by anything?
55.
It definitely does do about 55. Yeah, people would be tempted to do 11. That would be fine, but 55 is even better. What do you get?
1, 0, 0,
Huh?
and then negative 4.
And negative 4. Does the next row reduce?
5, 3.
Yes, and as a matter of fact, that's where it came from. So if you want a shortcut, go back one step. So what's the row?
21.
Uh-huh.
Negative 4.
Uh-huh.
0.
Good.
Negative
Negative 86. And then the bottom, just keep the same. 3, negative 1, negative 3, negative 22. Yes. So what should be our next target or targets? Nate, which two numbers are what? Yeah, the 3 and the 21 are going to be wiped out. What are you using as your club? The 1 up above them, which by the way is insanely lucky. It's really nice if you have a club of 1, you can multiply by anything. What number is big enough to catch 1, 3, and 21? 21, yeah. You can do 63 if you had to, but it's more firepower than you need. Can you magnify those up for me? What are you going to multiply the first one by? 21. I'm sorry? Okay. 21A. How about this one? Semi-trick question. Yeah, negative 1 sounds good. Why negative? Yeah, we need something to cancel them. And then 7. Now there's a little bit of a caution. I would change one thing. Which number are you using as your club? 1. So guess which one would probably be handy to be negative? The 1. The reason, if I had this as negative, I use this as club, it'll cancel this. But if I try and club this with this, it'll be positive 21, positive 21, that won't cancel. Does that make sense? Okay, so I'm going to do negative 21. Go ahead and do that for me. Give me the new matrix.
So negative 21.
Yep.
0,
Mm-hmm.
0, and negative 84, or positive.
Positive 84, good. Next row. Well, but you had 21, negative 2, 0, negative 2. And then the next one?
21.
21.
Negative 7.
Uh-huh.
Negative 1.
Uh-huh. And yeah, I'm sorry. Negative something. I do 7 times 20 and then 7 times 2. 150, 154, good. And we're targeting these. What code should I use for those two? B plus A? And C plus A. Give me the results. At the top is the same. Negative 21, 0, 0, 84. Go ahead. 0. Sorry. Negative 2. 0. What is this? It's negative. Oh, negative 86. I slopped that card. Negative 2. Nice. And then the bottom? Out. Okay. Okay. Well, it's 84 plus negative 154. Negative something. Well, take 154 minus 84. I subtract the 4 first, it's all easier. So 150 minus 80. Yeah, 7. Everybody okay so far? We just wiped out the first two numbers. Blaze, take over. What would I do before I do anything else?
Reduce.
Most definitely. Does the top reduce?
Yeah.
Yeah, by what?
4. Or 21.
By 21. As a matter of fact, by
Negative 21.
negative 21. What is, does the second row reduce?
Yeah.
By what?
Reduce.
Definitely. Does the third reduce?
Yeah.
By what?
Negative 7.
Yeah, nice. Give me that.
Maybe 1,
Uh-huh.
0, 0, negative 4,
Good.
0,
Uh-huh.
1, 0, 1,
Okay.
and 0, 1, 3, 10.
Got it. One more number to wipe out. Let me see. Sam, what's the last number we want to wipe out? It'll look like this.
1,
The 1. On the top row, middle row, or bottom row?
bottom row,
Bottom row. I want to take this out. What are you going to use as the club?
the 1 above it.
The one right above it. So, can you give me some way to get these to cancel?
Multiply the top one by negative 1.
Okay, multiply the top by negative 1. So negative 1b, and leave the other one alone. So it'll be 1, 0, 0, negative 4. I'll just turbo this. 0, negative 1, 0, negative 1. 0, 1, 3, 10. Go ahead and do that. What code would I write?
B plus C,
Yeah, in which row?
the bottom one.
Bottom row. Good. So b plus c. Go ahead and do that for me. And yes, if you haven't noticed, these are huge. Okay.
So the top row is the same.
Yeah, 1, 0, 0, negative 4.
And then 0, negative 1, 0, negative 1.
Uh-huh.
And then 0,
Uh-huh.
0, 3, and 9.
And then what's that?
9.
9. Yeah, right. So we've got, does anything reduce?
The bottom row by 3.
Definitely. Anything else?
The middle row by negative 1.
Yes. Middle row, the middle row by negative, wow. The middle row by negative 1. So it's 1, 0, 0, 4. Keep going.
0, 1, 0, 1.
Good. And
0, 0, 1, 3.
what's your final answer?
X is 4. Y is 1, and Z is 3.
You're done. Ta-da. Welcome to the glorious world of 3 by 3 augmented matrices. Well, okay, 3 by 4, technically. Yeah.
It's a bit negative 4.
Is it negative 4? Oh, that's something wrong. Yeah, thank you. Save my business. So, questions? And, yeah, it's tedious, I'll be quick with that. But there is, you gotta admit, there's a certain sense of satisfaction when you get to nail that thing. I mean, it's hard shooting, I was gonna say cows, but, moles. I actually am in the mood to shoot moles because they're digging up my garden, but it's kind of, all right, ready, aim, bam, 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 done. There's just a certain amount of smoke a feeling at the end of this when you do it. Yeah, okay.
Are we gonna do bigger ones, or is this bigger?
Oh, heavens, no. Yeah. Could you theoretically do bigger ones? Yes. What you would do, I think I demoed that, you would do this, then this, then this, then this, then this, long, shorter, 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 and then you would do long, shorter, shorter, shorter. Basically, you do this whole, like a little triangle up here, then this little triangle down here, in columns. Yeah, but no. That might be an interesting extra credit question. Okay. Yeah, both sides. Is everybody, I hesitate to ask if everybody's comfortable with this, because I think the answer is no, even if you can do it in your sleep. But does everybody kind of understand this? All righty. Put that away, please. Take out your notes. I want to talk a bit. The next section on the homework, by the way, we are skipping. It's 3x3 determinants, and we already did that. So if you, on your homework guide sheet, if you could scratch off homework 4J as in jackrabbit, that is not going to be done because we already did that. Let's see if we can have a pencil for more way. So 4J to scratch off. We're leaping into 4K. I want to talk a bit about something that at least hopefully should be a review from last year. Any questions? Anybody need anything up in here before I read? Speak now for everybody. Okay. Now, as a review, hang on, let me take a sip of water. It's called the mathematician show. Now, quick review example. Graph the following. Y is equal to 3 over 4x plus 1. We had a test on this, so it should be relatively fresh. First, can someone, for example, ready? What form is that? It is slope-intercept form, correct. This is slope-intercept form. It's y equals mx plus b. If I want to graph this thing, where would I go first? At what?
Is it the y?
The y-intercept, correct. The y-intercept is your starting point. Okay? So is it one up, down, left, or right? One up, correct. So it's positive and it's a y-intercept, not x-intercept. So where do you go from there? Blaze, take over.
Then do slope.
Slope. What is slope?
Right and left.
Right. Correct. So slope is rise over run. So go ahead and do that. What would I do?
Go up through
From where?
from the y-intercept.
From the y-intercept. Yeah, don't start over from 0. So you go up 3, and then what?
So the right 4.
You don't have to do the dotted lines. I just think it looks cool. 1, 2, 3, 4. Blah, 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 blah. Dot, and then what?
You connect them.
Yeah. Connect them and draw what?
Arrows.
Arrows. Correct. The arrow show goes first. Ta-da. And the problem. But, however, what if I wanted you to graph this? It's still in slope-intercept form. It still has a y-intercept of 1. Still has a slope of 3 or 4. But something's different. Describe it for me, if you'd be so kind. All math people. What would be different? It's still graphing. And I'll give you a little bit of a review. You remember when we graphed on a number line? Way back when? If you had like x equals 2, you just go on a number line, here's 0, You go over to 2 and you put a solid dot, and that's it. And then if I did x is greater than or equal to 2, you go over to 2, you put a solid dot, but you also shade to the right. Remember that? Yeah.
Is this with the lines where you shade it in and then the dotted lines, right?
Correct. Solid or dotted lines, depending on which one you need. Yes. Over here, what if I had x is greater than 2, but not equal? Can anybody tell me what would be different over here? Yeah. Open circle, and then shade which way? Yeah, still to the right. I want all the numbers bigger than 2, but I don't want to include 2. Does that make sense? Now this is what I call a one-dimensional graph. That's kind of a cosmic word to use here. What is a dimension? It's a pair of directions to move. Like forward, back is one dimension. Left, right is another. Up, down is the third. So we are three-dimensional creatures. If we were all crushed flat, we would be two-dimensional creatures. That's why a friend of mine in college, I picked it up from him because I thought it was really funny. He was a little more rough of speech than I was. He couldn't tell by my violent story problems, but I sort of picked that up from him too. And he was driving, and he would, there'd be this dog that would run across the road, and he'd slam on the brakes, and he was a math guy too. Hey dog, if you want to stay three-dimensional, get off the road. Basically, if you stay on the road, you're going to get flat. Which I thought as a math person was funny, but nobody else in the car got it. But whatever. A two-dimensional graph looks a little different. You have to do one of these things. A one-dimensional graph is just one line. A two-dimensional graph is two lines crossed. So could I graph x equals 2 on a two-dimensional graph? Yes, we've actually done that. You go to the right 2, just like you did before, but instead of a solid dot, you have a solid line at x equals 2. Does that make sense? It's the entire line. It's, the way I put it sometimes is, excuse me, blood, Holy Family. I'm putting a marker in front of them. Like, this is my offering to the Holy Family. It's probably off screen. The people at home have no idea. I just put it, it was just dumb. Now, how do you get a 2D graph out of a 1D graph? You basically grab the top and bottom and pretend it's made out of like rubber or taffy or something, and you stretch. So this dash at 0, if you stretch it, it becomes the y-axis. And you take this little 2 dot here, I think it's like an infinitely stretchable, like gumball or something, or gumdrop, or silly putty, that would work. A little blob of silly putty here. They still make that, right? Okay, good. And then you just stretch, and it becomes a line. It's the same graph, just stretched. Same thing's going to happen here. Thank you, William. If x is greater than or equal to 2, you notice there's still that solid dot that gets stretched into a solid line. But do you see the shading going to the right? You shade to the right. Why am I doing this? Because I want to save ink. In the real world, if I got a computer, if I graphed this thing, this whole thing would be solid blue. I just don't want to waste my marker. You know, you take a bucket of blue paint, go on this side, and that's what it would look like. Okay? X is greater than 2. What does that look like on a 2D graph? Same thing, you go to the right 2, but now we have an open dot. One way to think of an open dot is you can see daylight through it. Like, oh look. And what kind of, you notice a solid dot you can't see through. Same thing with a solid line. But if you have an open dot, you can see through it. What kind of line can you draw that you can see through? Yeah, go.
Dash line.
A dash line or a dotted line. That's exactly what's going to be the case. It's a dash line, but then also with the shading to the right. Does that make sense? A refresh a little bit? I have no idea why. All right, this is totally off topic, but the COVID thing's got me a little slap at the end. So there was this 30-second infomercial. I learned this from a kid at camp. I was a camp counselor for like 10 years. And this is like a 9-year-old kid. He came up and said, hey, how much you want to bet I can poke my head through this without opening it? And I fell for it. I said, I can poke it, how, you think I can? And I said, no, I don't think you can. I said, without opening your finger and thumb? Without opening. So there's a 9-year-old joke. The only reason I thought that is because I did that open thing where you said you can see daylight through it, and that just jogged that random memory, which I was it poke, as in, yeah. Anyway, moving on. You can get some people that way. Caution. You notice whenever you have an equal, it's going to have a solid dot. Same thing over here. When you have an equal of some stripe, you're going to have a solid line. It's only when you lack an equal sign when you have the dotted line. So over here, the only thing that's different, well, there are two things that are different. There's no equal sign, which means it's going to be open. Here's what you do. You still have the same y-intercept. You go up 1, but you don't put a solid dot. You put an open dot. And then do the same slope thing. Up 3, rise 3, run 4. Open dot. What kind of a line do I draw? A dotted line. It's going to look like this. Now there is one other thing. The fact that you have a less than or a greater than means you're going to be having some shading. Like on a number line, it's a little easier to see. If it's greater than, it shades to the right. If it's less than, it shades to the left. This isn't quite as easy because you also have up and down to worry about. But does everybody see that there are only two sides of a line? Like the upper left and the lower right? One of those two sides is going to get shaded, and I don't know which. Does anybody remember how? How do you tell which one is going to be shaded? Good question. And by the way, this is actually one of my favorite math metaphors in the world. Partially because, you've had a lot of theology courses, moral theology, and training and how to be a virtuous person, blah, 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 blah. I can encapsulate the entire Christian moral life in one math story problem. And this is it. Get ready. This is exciting. How do you tell which way to shade? Now, does it make sense that, like, everybody looks at this formula, y is less than 3/4 x plus 1, and they kind of, if you're anything like me when I was back then, I just thought of it's a magical new formula. It has nothing to do with plotting points. You remember the good old days when they say, can you plot point 2, 5? Oh boy, 2 to the right, 5 out. And that was the end of the problem. Well, wasn't life nice back then? But it's the same thing. What do I mean? X stands for all the points that are how far over, and Y stands for the part of the points that's how far up. So if I pick a point, let's say 2, 5, I can plug it in if I wanted. Now, you might notice that if you plug some stuff in, sometimes it'll be true, sometimes it is less than, and sometimes it's not. Depending on 2, 3, 10, 10, 20, 5, some of them are going to work and some of them are not. Like just for giggles, let's try this. Quick example. Let's just say y is greater than 2x plus 1. Let's just take an easier one. What if I did the number 6, 10? I want to know, will this work? Well, let's find out. What is y according to this? 10. You notice every point is x, y. They're called x, y for a reason. Because not only can you plot them in the good old days, you can plug them in. Let's see what happens. 10 is greater than 2 times what? Keep going.
2 times 6.
2 times 6 plus
1.
1. Go ahead and do this. 10 is greater than what?
12 plus 1,
12 plus 1, better known as?
13.
Did it work?
No.
Is 10 greater than 13? No. Came up false. Oh, it's so sad. Sometimes it comes up true. Sometimes it comes up false. Why do I bring this up? Glad you asked. So, I really miss being able to do that sort of semi-sarcastic grin. Moving on. How do I tell which way the thing is shading? Let's put it this way. I left myself some room, darn it. All true, quote unquote, true points. What do I mean? Points that if you plug them in and they're true. All true points will be shaded. Will be, I'll say, will be covered by shading. In other words, they're all solid dots. How do you tell just by looking at a graph whether a point is good or bad? Is it shaded or not? If it's shaded, it's good. If it's not shaded, it's bad. That's not the moral lesson, by the way. I'll tell you when that comes. But here's the fun thing. Pretend this is a fence. This dotted, slanty fence. And I'm going to take a huge bucket of infinite paint and paint either one side or the other, but I just need to know what's the correct side. Because if you paint an infinite side of one fence and you get it wrong, people get very angry at you, I understand. So, am I supposed to shade above or shade below? The way we do this, so in other words, which way do we shade? That's the main question of the day. Which way? Here's how. Write this down, please. You test a point. Test a point that's not on the line, not on the border. And here's where the fun part comes in. You test a point. If it comes up true, you shade toward it. If it's false, you shade away from that point. I should write that in. That point. Semicolon. Semicolon. You can pick any point you want as long as it's not on the boundary. Anybody have any suggestions? I would recommend pick something that's easy. Can I recommend a point that's just insanely super duper easy, if you can remember?
4-2.
4,2, sounds good. By the way, I'll use that. Can we think of an easy, nicer one? 0, 0. When you plug that in, it's super duper easy. I'm going to do 4,2 just because I'm feeling courageous here. And I'll join you in the courageousness. You inspired me. I'm going to put a little X at 4,2. And I want to test this in the formula. It'll look like this. 2 is less than 3/4 times 4. I love the 4, by the way. Plus 1. Why? Because it cancels the other 4 and makes the job a lot easier. What's 3/4 times 4, anybody? Where'd you go?
3.
3. So 2 is less than 3 plus 1. What's your verdict? Is that true or is that false? Okay.
It's true.
It's true. It's 2 is less than 4. True. You tested this side and it came up true. Did I hit the correct side? Well, you hit the correct side. I didn't. Okay. Did we hit the correct side or did we not? Please.
Yes.
Yes, we did. Guess what we should do with that side?
Yeah.
Shade it. Shade toward it. By the way, you could take I have seen some people do this. They take a pencil and they do this amazing artistic, so it's just immaculately shaded. It's like art class, 305. And I'm imagining the pencil is about this long by the time they're done with the problem. But you can just draw a couple of lines, that's just a saving. Does that make sense so far? I promised you a moral lesson. According to shading problem, you test a point, you test something in life. If it's true, you run toward it. If it's false, you run away from it. Thank you, thank you, thank you. Who needs the catechism? You, by the way, I'm kidding. No. But do you see? If something tests true, go toward it. If something is false, run away from it. If everybody did this, we would not need any jails, anything. Okay, enough of the soapbox. Everybody clear on this? Okay, yeah, good.
Could you?
Okay. Let me hand this out. There's an interesting mix of views on this one. This is not due tomorrow. This is going to be due on Wednesday. And yes, I know, we're probably going to be staring at each other through a digital medium. Don't get me started. I'll probably spend the first 2 minutes of virtual class on Wednesday whimpering, but yes. Anyway, what I'd like to do is look this over. You do have enough notes to do some of these. You're welcome to. The entirety of the thing is due on Wednesday, but I'm going to give you notes on the second half of this tomorrow, so that you can do absolutely everything. And that should, okay. I think we are up against the wall. Wow, I have 18 seconds to spare. This looks good. Please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Yeah. Thank you. Have a good day, y'all. Stay safe. Thank you. Staying on virtual for the day. Good to see ya.
Thank you, Mr. Travelers.
Thank you. Have a good day, y'all. Oh, I just turn off the iPad too. Okay, people at home, God bless you all. Talk to you later.